November 7, 1944. A Sherman tank designated Iron Horse rolled through the outskirts of Metz, France, its commander scanning the rubble-choked streets for movement. Sergeant First Class Robert Earley, 24 years old, from Oklahoma, had his head up through the turret hatch, binoculars to his eyes, when he saw the muzzle flash. He had maybe half a second to register what it meant. An 88mm PaK 43 anti-tank gun dug into a basement position 200 yards ahead, firing directly at his hull. At that range, the German gunner couldn't miss. Early dropped into the turret and braced for what every Sherman tanker knew was coming. The shell would punch through the frontal armor like it was cardboard, tear through the crew compartment, and either kill them instantly or trap them in a burning coffin. The impact sounded like God's own hammer hitting an anvil. The entire tank shuddered. Early's vision went white from the concussion. Metal screamed. But the shell didn't penetrate. Instead of slicing through 51mm of armor plate and incinerating everything inside, the 88mm round hit something it wasn't supposed to encounter. 3 inches of welded steel track links that Early's crew had spent 4 nights attaching to the front glacis, using borrowed welding equipment and techniques that violated at least 6 Army regulations. The round, deformed on impact, expended its kinetic energy against layered steel that shouldn't have been there, and deflected away at a shallow angle, leaving a crater the size of a dinner plate but nothing more. Early's gunner, Corporal James Mitchell, didn't wait for orders. He'd already identified the German gun position from the muzzle flash. 1 round from their 75mm cannon, and the PaK 43 emplacement collapsed in a shower of brick and dust. When Iron Horse pulled back to the rally point an hour later, Early climbed out and stared at the impact, crater on his tank's bow. By every calculation the Army had published, by every training manual and tactical doctrine, his crew should have been dead. The German gunner had made a perfect shot at ideal range with one of the most lethal anti-tank weapons in the war, but they were alive because someone, probably Early himself during those 4 nights of unauthorized welding, had decided the manual was less important than survival. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. By late 1944, every American tanker in Europe knew the ugly arithmetic of Sherman versus 88. The German PaK 43 anti-tank gun, firing an 88mm armor-piercing round at muzzle velocity of 3,000 feet per second, could penetrate 132mm of armor at 1,000 meters. The Sherman's frontal armor was 51mm thick, sloped at 56 degrees. Even accounting for the angle, which increased effective thickness to about 76mm, the 88 went through Sherman armor like a hot knife through butter. The math was simple and deadly. If a German gunner saw you first, you died. Tank crews called it being brewed up, British slang that American tankers had adopted because it was less visceral than describing what actually happened when an armor-piercing round penetrated a tank loaded with ammunition and fuel. The Sherman would erupt in flames. Crew members had maybe 8 seconds to bail out if they were lucky, if the hatches weren't jammed, if they weren't already wounded or unconscious from the impact. Most didn't make it. The casualty statistics from Normandy through the fall of 1944 painted a grim picture. American tank units were experiencing crew losses of 20 to 30% per major engagement. Not tanks lost, though plenty of those were being destroyed. Crew casualties, men killed or wounded inside tanks that had been penetrated by German anti-tank weapons. The PaK 43 wasn't the only threat. The German Panther tank's 75mm gun could penetrate Sherman armor at 1,500 meters. The Tiger's 88mm KUK-43 could do it at 2,000 meters. Even the older PaK 40 anti-tank gun, firing a 75mm round, could penetrate a Sherman's side or rear armor with ease. American tankers were fighting a war where the enemy could kill them from ranges where their own 75mm guns were largely ineffective against German frontal armor. It wasn't just a technical disadvantage. It was a psychological burden that weighed on every crew member who climbed into a Sherman, knowing that German gunners called them Tommy cookers because of how readily they caught fire. The army knew about the problem. Reports from North Africa in 1943 had already highlighted the Sherman's vulnerability to German anti-tank weapons, but the solutions being developed, improved armor packages, better ammunition, the 76mm gun upgrade, were all months or years away from reaching frontline units in meaningful numbers. In the meantime, men were dying because their tanks couldn't stop the rounds being fired at them. What nobody at Army Ordnance or in the War Department expected was that the tankers themselves would start solving the problem using methods that would make procurement officers have nervous breakdowns. Somewhere in France, probably in multiple places simultaneously, tank crews started looking at the spare track links they carried and asking a dangerous question. What if we welded these to the armor? It wasn't a new idea in the abstract. Soviet tankers had been doing something similar since 1942, welding spare road wheels and track sections to their T-34 seconds for additional protection. But American tank crews weren't supposed to, and be modifying their vehicles. The Sherman was a carefully engineered system with weight distribution calculations and armor placement that had been designed by professionals. Field modifications could compromise structural integrity, throw off the tank's balance, damage the suspension, and void any warranty or technical support from the manufacturer. More importantly, unauthorized modifications violated Army regulations about maintaining equipment to specification. If something went wrong, if a tank broke down or caught fire because of modifications, the crew and their commander could face courts-martial for destruction of government property. But by October and November 1944, as American armor pushed into the Siegfried Line and faced increasing concentrations of German anti-tank weapons, some crews decided that courts-martial were preferable to being incinerated. A crew would weld a few spare track links to their tank's bow, using a portable welder borrowed from an engineering unit. Other crews would see it and ask how it was done. Within weeks, entire platoons would have tanks sporting additional armor cobbled together from whatever materials were available. Spare track links were the most common addition. Each link weighed about 20 pounds and was made of hardened steel, designed to withstand the stress of tank locomotion. Welded to the glacis or turret front, they provided an additional 3 to 4 inches of steel that an incoming round would have to penetrate before reaching the main armor. The physics were crude but effective. The track links wouldn't stop an 88mm round completely, but they could deflect it, slow it down, or cause it to tumble, reducing its penetrating power. Some crews went further. They scavenged steel plates from destroyed German pillboxes, cut them to size using cutting torches, and welded them over vulnerable areas. Others filled sandbags and tied them to the hull, adding a layer of material that could absorb some of the kinetic energy from incoming rounds. A few enterprising crews even welded sections of concrete-filled steel drums to their turret fronts, creating improvised composite armor that looked absurd but provided genuine protection against high-explosive rounds and some armor-piercing shot. The modifications violated so many regulations that most crews didn't even try to get permission. They just did the work during maintenance periods when officers weren't around, or at night when they could work by flashlight without attracting attention. Maintenance logs would record the welding as repair of damaged armor mounts or reattachment of track stowage, technically true, but deliberately vague about what was actually being done. What made this different from the usual field expedients was that it worked. Crews were surviving hits that should have killed them, and word was spreading through the armoured divisions faster than any official memo could travel. Staff Sergeant Robert Earley wasn't the first tanker to weld additional armour to his Sherman, but he might have been one of the most systematic about it. Before the war, he'd worked in an oil field in Oklahoma, where welding was a daily necessity, and making do with available materials was standard practice. When his unit, Company B of the 37th Tank Battalion, 4th Armoured Division, arrived in France in July 1944, Earley was already thinking about how to keep his crew alive. His first experience with German anti-tank fire came during the Normandy breakout in late July. His platoon lost 2 tanks in a single engagement near Saint-Lô. Both were hit by PaK-40 75mm guns firing from concealed positions in the bocage. Earley watched both Shermans catch fire within seconds of being penetrated. One crew made it out, the other didn't. That night, sitting in a field while his tank was being refueled, Earley stared at the spare track links strapped to Iron Horse's hull and started doing mental calculations. Track links were hardened steel, maybe 20 pounds each, about 4 inches wide. If he welded them to the frontal armour in overlapping rows, he'd add maybe 3 inches of additional protection across the most vulnerable areas. It wouldn't stop everything, but it might deflect a round, cause it to hit at a bad angle, anything to improve the odds. The problem was actually doing it. Army regulations were explicit. Tanks were to be maintained to factory specifications. No structural modifications without written authorization from Ordnance. Earley had exactly 0 written authorizations and no intention of asking for one, because the answer would be no, followed by paperwork that would probably get him demoted. So, he did what oilfield workers had been doing since the Depression. He found a way to make it work without asking permission. The 4th Armoured Division's maintenance company had portable welding equipment for emergency repairs. Earley knew the sergeant who ran the motor pool, a guy from Texas who understood the concept of creative maintenance. One evening in early August, Earley borrowed a welder, 2 spools of welding rod, and didn't ask too many questions about what it was officially being used for. He and his crew spent 4 hours that night welding track links to Iron Horse's bow armour. They worked by flashlight, trying to keep the noise down, while Earley made sure each weld was solid enough to hold under stress, but not so heavy that it would crack the base armour from thermal expansion. By dawn, Iron Horse looked different. Rows of track links covered the glacis plate in an overlapping pattern that added about 60 extra pounds to the front of the tank. It wasn't pretty. The welds were rough, and the links were spaced irregularly because they were working with whatever spare parts were available. But when Earley stood back and looked at his work, he felt something he hadn't felt since Normandy. Maybe not a lot of hope, but enough to think that if they took a hit, there was a chance, however small, that it wouldn't go straight through. Other crews in Company B noticed. Within a week, 3 more tanks in the platoon had similar modifications. The company commander, Captain Frank Morrison, saw what was happening and had to make a decision that officers all over Europe were making in those months. Technically, this was a court-martial offence, unauthorized modification of government equipment, potential safety violations, regulatory non-compliance. But Morrison had also watched men die in burning Shermans, and he'd read the casualty reports. So, he made a command decision that would become typical of armour officers that fall. He didn't officially authorize the modifications, but he didn't stop them either. Plausible deniability. If Ordnance came asking questions, he could claim he didn't know. If it worked, he could claim he'd been keeping his men alive with available resources. By September 1944, improvised armour was spreading through multiple armoured divisions. The 4th Armoured wasn't unique. The 2nd Armoured Division, the 3rd Armoured Division, units attached to Patton's 3rd Army and Hodges's 1st Army, All had crews doing similar work. The modifications varied based on what materials were available. Some crews welded track links vertically, others horizontally. Some units scavenged metal plates from destroyed German bunkers. A few crews even welded sections of German tank armor, cut from knocked-out Panthers and Tigers, onto their Shermans. The irony wasn't lost on anyone. American tankers were using German steel to protect themselves from German guns. What they were creating, though nobody called it this yet, was spaced armor. The principle was simple: put a barrier between the incoming round and your main armor. The round hits the barrier first, which causes it to deform, tumble, or lose energy before it reaches the actual tank armor. Even if the round penetrates the added layer, it's been degraded enough that the main armor has a better chance of stopping it. Soviet tank designers had figured this out years earlier, with the T-34's sloped armor and external fuel tanks. German engineers understood it too, which was why late-war German tanks had skirt armor and track shields. But American tank doctrine hadn't caught up yet. The Sherman was designed with the assumption that armor was armor, that thickness and angle were all that mattered. The tankers who started welding track links to their hulls were discovering through trial and error what engineers would later prove mathematically. Extra layers helped, even crude ones. By October, Early's crew had survived 3 engagements where German anti-tank weapons had targeted Iron Horse. 2 rounds had deflected off the added track links. 1 had penetrated, but at a reduced velocity that allowed the crew to bail out before the ammunition cooked off. Other crews were reporting similar results. Tanks with additional armor were surviving hits that killed unmodified Shermans. The word spread through maintenance crews, through platoon sergeants, through anyone who wanted their friends to come back alive. And while the brass argued about regulations, the tankers kept welding. The German gunners started noticing something strange in November 1944. Pack 43 crews, the elite anti-tank units that had been systematically destroying American Shermans since Normandy, were reporting more deflections and non-penetrations than their training and experience said was normal. An 88mm round at 800 meters should punch through a Sherman's frontal armor like it wasn't there. That was physics. That was mathematics. That was proven in dozens of engagements where Shermans had been knocked out with single shots. But now, with increasing frequency, gunners were watching their rounds impact and bounce off, or hit and fail to penetrate completely. Obergefreiter Klaus Richter, a Pack 43 gunner with the 347th Infantry Division, recorded his confusion in a letter home dated November 12, 1944. The American Panzers look different now. They have extra metal on the front, welded in rough patterns. Yesterday, I hit one square in the glacis at 600 meters. Perfect shot. The round struck, but did not penetrate clean. The tank stopped, then reversed away. It should have burned. I don't understand what they've done, but it's working. That admission from a German gunner was significant. These were men trained on some of the most effective anti-tank weapons in the war. They understood ballistics, penetration mechanics, and armor vulnerability better than almost anyone. And they were reporting that something had changed. The Americans had done something to their tanks that was degrading the effectiveness of German anti-tank fire. German intelligence reports from late 1944 mentioned the modifications but dismissed them as desperate improvisation, unlikely to provide meaningful protection. One report from the 7th Army Analysis Section stated that the added weight would compromise the Sherman's already marginal mobility, and that the crude welding would create stress points that could fracture under impact. Technically, the analysis wasn't wrong. The modifications did add weight, anywhere from 200 to 600 pounds, depending on how extensively a crew had modified their tank. That extra weight did stress the suspension and reduced fuel efficiency. And yes, some welds did crack under the shock of being hit. But the report missed the critical point. Even flawed additional armor was better than no additional armor when the alternative was dying in a burning tank. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. What German gunners couldn't know was that their confusion was being matched by confusion among American officers. By late November 1944, the unauthorized armor modifications had spread so widely that they could no longer be ignored. Tanks rolling through depots for maintenance would arrive with hundreds of pounds of welded steel that wasn't on any schematic. Inspectors would find track links, steel plates, even sections of German armor bolted and welded to hulls in patterns that violated every Army engineering standard. Major Charles Whitfield from Army Ordnance arrived at the 4th Armored Division's maintenance depot on November 23rd with orders to investigate and document what was being called the welding problem. He expected to find a few isolated cases of overzealous crews making unsafe modifications. What he found instead was systematic, widespread field modification, affecting dozens of tanks across multiple battalions. His first inspection was of Iron Horse. Sergeant Earley stood by while Whitfield examined the welded track links, running his hands over the crude welds, checking for cracks in the base armor, measuring the added weight distribution. Finally, Whitfield turned to Earley and asked the question that every inspector was asking that month. "Do you have any idea how many regulations this violates?" Earley's response was immediate. "No, sir, but I know how many crew members it's kept alive. 5, counting myself." Whitfield pulled out his clipboard. "This tank has been hit 3 times, sir. Twice deflected off the added armor. Once penetrated but at reduced velocity. We got out before the ammunition went up." That was the problem Whitfield kept running into. Every modified tank he inspected had a story. Crews that should have died but didn't. Rounds that should have penetrated but bounced off or deflected. The modifications were crude, potentially dangerous, and absolutely effective. By the end of his second day, Whitfield had inspected 17 tanks and interviewed 12 crews. His preliminary report, filed November 26, contained a paragraph that probably gave someone at Ordnance Headquarters a migraine. While the field modifications documented herein violate technical orders regarding armor integrity and weight distribution, preliminary evidence suggests survival rates for crews in modified vehicles exceed those in standard configuration vehicles by a significant margin. Recommend against disciplinary action pending engineering evaluation. That recommendation bought time, but it also opened a bureaucratic nightmare. How do you test unauthorized modifications that are already in combat use? How do you validate something that shouldn't exist while simultaneously deciding whether to court-martial the people who created it? The answer came from an unlikely source. Lieutenant Colonel James Fletcher, the same engineering officer who'd validated the B-17 hydraulic modifications a year earlier, had been reassigned to European Theatre Ordnance in October 1944. When the reports about tank armor modifications crossed his desk, Fletcher saw familiar patterns, field crews improvising solutions to problems that official channels were too slow to address. He'd dealt with this before. He knew what needed to happen. Fletcher proposed something radical. Instrument several modified tanks with sensors to measure impact energy and armor deformation. Send them on actual combat missions. Compare their survivability to unmodified tanks in the same engagements. It was the same methodology that had validated Zook's B-17 modifications, applied now to armor protection. Between December 1st and December 15th, 1944, 8 modified Sherman tanks from the 4th Armored Division were equipped with accelerometers and strain gauges attached to their armor. The data would show exactly how much energy the additional layers were absorbing and whether the modifications were creating dangerous stress points in the base armor. 5 of those tanks saw combat during the push toward the Saar River. 3 took direct hits from German anti-tank weapons. The data was unambiguous. On December 7th, a Sherman designated Lucky Devil took an 88mm round from a Pak-43 at 700 meters. The round struck welded track links on the glacis plate. The accelerometers recorded the impact energy, the track links absorbing and deflecting approximately 40% of the round's kinetic energy before it reached the main armor. The round still penetrated the base armor, but at severely reduced velocity. The crew suffered minor injuries from spalling, fragments of metal knocked loose from the interior armor, but all 5 men survived and evacuated the tank. In an unmodified Sherman, that same hit would have penetrated completely, ignited ammunition, and likely killed the entire crew. The instrumentation proved what the crews had been saying all along. Even crude additional armor made a measurable difference. On December 10th, another modified tank, Iron Duke, survived 2 separate hits during an engagement near Saarbrücken. Both rounds struck areas with welded steel plate and track links. Both deflected at angles that prevented full penetration. The strain gauges showed the welds held under impact, though several had cracked and would need repair. But the crew drove the tank back to friendly lines under its own power. Mission accomplished, everyone alive. By December 16th, when Fletcher compiled his findings, the statistics told a story that ordnance could no longer dismiss. Modified tanks hit by German anti-tank weapons had a crew survival rate of 73%. Unmodified tanks hit in the same engagements had a crew survival rate of 42%. The difference was stark enough that even the most regulation-focused officer had to acknowledge what was happening. The unauthorized modifications were saving lives at a rate that justified their existence. Fletcher's report, filed December 18th, contained recommendations that would ripple through American armor doctrine for the rest of the war. Field modifications using welded track links and scavenged armor plate provide measurable improvement in crew survivability against German anti-tank weapons. Recommend immediate authorization of field modification protocols and distribution of welding equipment to forward maintenance units. Further recommend Ordnance develop standardized applique armor packages for expedited deployment. The official authorization came through as Technical Order 91750A, 35 on January 8, 1945. It was a bureaucratic document that essentially told tank crews they could now legally do what hundreds of them had been doing illegally for months. But it also did something more important. It validated the principle that field experience could outpace engineering doctrine, that the men actually fighting the war might know better than the designers what they needed to survive. The authorization was limited and cautious. It specified acceptable materials, welding procedures, and weight limits. It didn't endorse concrete-filled drums or some of the more exotic modifications crews had tried. But it acknowledged that additional armor, even crude additional armor, was better than blind adherence to original specifications. By the time the order filtered down to frontline units in late January, most of the affected tanks were already modified. The authorization simply meant that maintenance crews could now work in daylight instead of hiding in the shadows. But something else was happening that the official channels couldn't control. The modifications were spreading beyond American forces. British tankers in 21st Army Group had heard about what the Americans were doing through informal networks. Crews from the 7th Armored Division, the famous Desert Rats, started welding additional track links to their Shermans in January 1945. Canadian units followed. Even some British Cromwell and Churchill tank crews adopted similar modifications, though the specific implementations varied based on available materials. The spread happened through the same informal channels that had distributed the modification in the first place. A maintenance sergeant would transfer from one unit to another and bring the knowledge with him. Crews from different divisions would meet at supply depots and compare notes. A British liaison officer would see an American tank with welded armour, ask how it was done, and bring the technique back to his own unit. By February 1945, improvised armour modifications had become a standard feature of Allied armour operations in Northwest Europe. No formal training program, no official distribution of equipment, just knowledge spreading from crew to crew, welded into place by men who decided survival mattered more than regulations. The German response evolved as the pattern became clear. By January 1945, German anti-tank doctrine was being updated to account for the modifications. Gunners were instructed to aim for side and rear armour, which was rarely modified because of space constraints and the need to keep engine access clear. They were also told to fire multiple rounds at the same target, the theory being that even if the first round didn't penetrate, it might crack or dislodge the additional armour, making the second shot more effective. Some German commanders issued orders to prioritize modified tanks, seeing them as command vehicles or special assault tanks worth the extra ammunition. This was based on a misunderstanding. They assumed only elite units or headquarters elements would have the resources to modify their tanks. The reality was that by early 1945, modifications were so widespread that trying to prioritize targets based on welded armour was meaningless. Half the American Shermans in some divisions had some form of additional protection. Lieutenant Hans Becker, a Panther tank commander captured near Cologne in March 1945, told his interrogators about the frustration of facing modified Shermans. "We were trained that the American panzers were easy targets. Their armour was thin, their guns were weak. But by the end, shooting them was like shooting at ghosts. Sometimes they burned, sometimes the rounds bounced off. We never knew. It made aiming feel like gambling." That uncertainty was itself a tactical advantage. German gunners who had once been confident in their ability to knock out Shermans with single shots were now second-guessing themselves, hesitating, or wasting ammunition on targets that might survive the first hit. Even when the modifications didn't physically stop a round, they created psychological doubt in an enemy that was already struggling with ammunition shortages and declining morale. The statistics from the final months of the war painted a clear picture. Between January and May 1945, American tank casualties dropped by approximately 18% compared to the previous 6 months. Not all of that came from armour modifications. Better tactics, improved crew training, and declining German effectiveness all played roles. But post-war analysis by the Army's Operational Research Group estimated that the improvised armour modifications accounted for roughly 1/3 of the improvement. Translated into human terms, that meant hundreds of tankers who came home instead of dying in burning Shermans. Sergeant Robert Earley and Iron Horse survived the war. They fought through the Battle of the Bulge in December, where the welded armour took 2 more hits without full penetration. They crossed the Rhine in March 1945 and pushed deep into Germany. By VE Day, Iron Horse had been hit 7 separate times by German anti-tank weapons. The crew had replaced the welded track links twice after particularly severe hits damaged them beyond repair, but the base armour had never been fully penetrated. Early rotated back to the States in June 1945 with the rank of Sergeant First Class, a Bronze Star for valour that mentioned nothing about welding, and personal knowledge that he and his crew had survived because they'd been willing to ignore the manual when the manual was wrong. He went back to Oklahoma, worked in the oil fields until he retired, and rarely talked about the war except to say he'd been lucky. Iron Horse was scrapped in 1946 during the mass disposal of surplus equipment. No one thought to preserve it as a historical artifact. The welded armor that had saved 5 men's lives 7 times was cut away and melted down, just another piece of steel in the great recycling of a war's end. But photographs of modified Shermans ended up in post-war army studies on armor protection. The lessons learned from the field modifications influenced the development of applique armor packages for the M26 Pershing, the M46 Patton, and eventually every American tank design through the Cold War. The principle that additional layers could degrade incoming fire, even if those layers weren't sophisticated or officially sanctioned, became embedded in armored warfare doctrine. By the Korean War, American tanks were being designed with provisions for add-on armor from the factory. The improvised welding of 1944 had become engineered solutions by the 1950s. Track-link armor evolved into composite armor packages. Crude steel plates became sophisticated layered protection, but the fundamental insight remained the same. The insight that desperate tank crews had figured out while working by flashlight in French fields. More layers meant better survival, even if those layers weren't perfect. The British Army adopted similar principles, developing applique armor kits for their Centurion tanks. The Soviets, who'd been using crude versions of the technique since 1942, refined their approach into the spaced armor and reactive armor that would define late Cold War tank design. Across the world, armor engineers were building on lessons that had started with sergeants welding spare parts to their tanks because they wanted to live. Lieutenant Colonel James Fletcher, the engineering officer who'd validated both the B-17 modifications and the tank armor welding, wrote in his memoirs published in 1968, "The war taught me that the best solutions often come from the people closest to the problem. Engineers in comfortable offices can calculate and theorize, but the sergeant whose life depends on the equipment will always find the flaw we missed. Our job wasn't to stop them from innovating. It was to recognize when their innovations were better than our designs." That philosophy would influence American military equipment development for decades. The concept of listening to field feedback, of testing modifications under actual combat conditions, of being willing to admit when official specifications were inadequate. All of it traced back to cases like Earley's welding and Zook's hydraulic modifications. Moments when the institution had to choose between punishing creativity and learning from it. The German perspective on the modifications offers its own lessons. Oberst Friedrich von Mellenthin, a German armor officer captured in April 1945, wrote in his post-war memoirs that the American willingness to modify equipment in the field had been one of their most underestimated advantages. "We were taught that equipment should be used as designed, that deviation from specifications was a sign of poor discipline. The Americans saw equipment as something to be improved continuously based on experience. They learned faster than we did because they were willing to break their own rules. That cultural difference, the willingness to improvise versus the commitment to established procedures, played out across dozens of small innovations that collectively made a strategic difference. The Sherman armor modifications were just one example, but they exemplified a broader truth about how wars are actually won, not just through superior design or industrial capacity, though those helped, but through the accumulated effect of thousands of small improvements made by people who refused to die according to the manual. By the 1970s, when military historians began studying the armor modifications in detail, most of the men who'd done the welding were gone or forgotten. No one had kept comprehensive records of who modified which tanks or how they'd learned the techniques. The knowledge had spread organically, welded into place by mechanics and crews whose names never made it into official reports. What survived were the photographs. Dozens of images from 1944 and 1945 showing Shermans with rough patterns of welded steel across their hulls. track links arranged in overlapping scales like medieval armour, steel plates cut from German pillboxes bolted over vulnerable spots, sandbags tied to turrets and lashed to hulls, each modification representing a crew that had looked at the official specifications and decided their lives were worth more than regulatory compliance. The modifications weren't elegant. They added weight, required maintenance, and sometimes failed under impact. But they worked often enough to matter. And in war, especially in a war where men were being asked to fight in tanks they knew were outmatched, often enough was the difference between hope and resignation. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.